right, we're going to return to a problem from last time. And your teacher just spaced out or something because she was working it totally wrong. And so it was right to mark me wrong. So let's go through it the right way. This is a subtraction of fractions. For that, you have to have the common denominator. And so we factored this. And we said we're going to have different signs. And we're going to use a 9 and 4. And this sign will go with the biggest. Right? When you have these pieces that are negative reciprocals, so the x minus 4 and 4 minus x, those are called opposites or negative reciprocals. You don't have to use them both for the common denominator. So our common denominator can be x plus 9 times x minus 4. Right? So for the first one, we have that. For the second one, this we can turn into x minus 4, but it's going to need, to make it do that, we'll multiply it by a negative 1, and we will multiply by the missing piece, so the x plus 9. Do the same up here. All right. Now, as we get ready to work it out, remember that the common denominator you are going to keep. So I am going to keep x plus 9 times x minus 4. But the numerators you have to combine, so you actually have to multiply those out. This first one is okay because it already had the common denominator and we didn't have to multiply by anything. For the second one, though, we had to multiply by the missing parts. The negative 1 would turn this around to x minus 4. And we also needed the x plus 9. All right, so this, when you multiply it out, will give this denominator. So first of all, what's your signs? You have two negatives. That's going to make a positive, and that will take care of your signs. So we will have x squared plus 9x. All right, so we should combine on the numerator, and that gives us x squared plus 9 and 5 is 14x plus 7 over x plus 9 times x minus 4. Oops, 4. Now, you should try to factor the numerator to see if it will reduce, but 7 is going to be 7 and 1. That is not going to give you a 14, so it is not going to factor. That means the problem is not going to reduce. So this should be the correct answer, x squared plus 14x plus 7 over this. And sorry about that last time. I just spaced out and I didn't do any work on the next one. My thought was that they were forcing us to use x minus 4 and 4 minus x, which you do not have to do. You only have to choose one of those because you can make the other one match, but they weren't. I was just spacing out. All right, so we will let that one go there, but I wanted to show it to you correctly. So we'll move on to today's work. Anytime you guys have questions you want to see, please email me the problem numbers. I will be happy to do exactly what you want. All right, so we are moving into Module 8. And homework 1. And these are going to be solving equations with rational expressions. Lots of abbreviations there for you. Okay. So basically we are going to do equations that have fractions in them. Before we get there, there is something that we have to worry about now that we didn't really worry about when we did equations with fractions before. You cannot get an answer that would give you a 0 in the denominator because that would make it undefined. And because now we have variables that can be in the denominator, we need to look at that ahead of time and throw that out. The alternative is to check every single answer, and that's a lot of work. So it's a lot better to just state your domain at the beginning, and then when you finish a problem, look and see if you threw those values away. All right, so the first 3 questions just deal with that. Find all the values of the variable x for which the rational expression is undefined. So they're just giving us a plain fraction here. 7 over 6x plus 36. When is it undefined? And that would be when the denominator equals 0. So you're just going to take the denominator, set it equal to 0, and solve, and then that is the bad value that makes it undefined. So we're going to subtract. This is a linear equation. Exponent is 1. So subtract your 36. So we get 6x equals negative 36. And divide by 6. So x equals negative 6. So negative 6 is the bad value that makes it undefined. When they start asking it with their wording and they say domain, you're going to want to make sure you throw this away. But the way they've asked it here, they just want to know when is it undefined. So the bad value is negative 6. Right. 2 is the same kind of question. Find the values of the variable for which the rational expression is undefined. All you care about is the denominator. When is the denominator 0? Because those values would make it undefined. So we're going to set that denominator equal to 0. This one is a quadratic equation. The other one was a linear equation. The difference is the exponent, and then it's your solve method. So since it's a quadratic, we'll factor and use the 0 product law. We have a 0, so we'll factor. Like signs both minus. And how about 7 and 3? Multiplies to give 21, adds to give 10. Then solve each one, so x equals 7 and x equals 3. These 2 answers make it undefined. So 3 and 7. So those are bad. Right. One more here of this kind, except this one uses the term domain, and so you'll want to make sure that you're throwing those values away with a not equals. Right? So find the domain of this function. When you're working on domain, you have the set of real numbers, and then from the real numbers, you have 2 exclusions to worry about. You have denominators, which can't be 0, and you have radicals. We don't have a radical here, so we do not want this denominator to be 0. That would make it undefined. So it is a quadratic. We're going to set it equal to 0 and solve so we can throw those values away. So we will factor different signs, and let's see, we could use 10 and 5. And we want a plus 5. So we need to do plus 10 minus 5. Right? And that's minus 5 plus 10 and negative 50. So we're good there. So x plus 10 equals 0. Or x minus 5 equals 0. So this is x equals negative 10 and x equals negative 5. Remember, we're throwing those away. So we're going to have to say x cannot equal those. And so we're going to pick here. Now, they are writing the domain in what's called set builder notation. So the correct one would be the set of all x such that x is not equal to negative 10 and x is not equal to negative 5. Right, so this one is going to be your choice. Right. Next, I skipped down to problem 10. Just to pick a couple that were closer to what we're used to working. All right, so we have an equation that has fractions. You're going to find the common denominator, multiply through by it to make all the denominators cancel. And then you will solve whatever's left. Because we have a variable in the denominator, we have to state our exclusions, anything that would make it undefined. Now, the only one that's in the denominator is this a. So, and it's just by itself. So the only bad value is a can't be 0. So when we're done, we have to look back and make sure we didn't throw that away. Right. The other step we need here is we need to find the LCD. Well, the only denominator we have is a, so a is going to be the LCD. So we're going to multiply all the way across by a so that all the denominators will cancel. Right, this one's gone. So we have a squared plus 16 equals negative 10a. Right, and this looks like a quadratic equation. So let's move the a over. So a squared plus 10a to move it to this side plus 16 equals 0. And we'll try to factor this. So a, and we're multiplying to get 16. 4 and 4 is not going to do it. How about 8 and 2? All right, make sure you factored right. That gives us 10 and 16 there. So now you're going to set each one equal to 0. A plus 8 equals 0. A plus 2 equals 0. And solve. So you're going to subtract 8. And you're going to subtract a 2. Right, those are our answers. We have to look back and make sure that we did not throw either of those away. No, we threw away 0, so we're good. These are our answers, negative 8 and negative 2. Good. All right. Next I picked 16. And then we'll go back and do some of those others. All right, and I picked this because it has monomials for denominators, so a little bit more maybe like what you're used to. So 5 over 6x plus 7 over 24 equals 7 over 30x. All right, so it is an equation. Make sure it's an equation. The first thing is to decide what to throw away. So you check all your denominators and see when it would be 0. It's going to be 0 itself on this one. So you set 6x equals 0, divide by 6, so x equals 0. That's your bad value there. Nothing from this one because there is no variable. This one is going to solve like the first one. 30x equals 0 divided by 30. And so x equals 0. So the only bad value is 0 itself. So we have to throw that out. That's step 1. All right, step 2 is find your LCD. All right, for the numbers, we have to get something that they will all go into, and they have to all go into this 30. 24 won't go into 30. So we're going to have to go bigger. You can try the multiple method. Take the largest one and do multiples of it. So 30 times 2 is 60. 6 will go in there, but will 24. So 60 divided by 24. And no, it does not. So that doesn't work. That was not what I wanted to do. All right, so then your next multiple would be 90. 30 times 3 is 90. So you test, does 24 go into 90? And no, it does not. So you can keep going higher with the multiples, right? The next one would be 120. That one's probably going to work. So that's 30 times 4 is 120. If it doesn't, I'm going to go a different way. All right, so 120 divided by 24. Okay, that one goes. So 120 is going to be the number part. You also have to have this variable. So 120x is your LCD. The other thing you could have done prime. So we'll just sidetrack a second. 2 times 3 times x. 24 is 6 times 4, and we have 2 and 3 and 2 and 2. 30 is 6 times 5. You have 2 and 3 and 5. When you're picking an LCD, you have to cover every type of thing you have. So we need 2s, 3s, 5s, and of course x's. You take it from the one that has the most. So when you pick out your 2s, this one has 1, this one has 3, and this one has 1. You have to take 3. So we have to take 3 2s. All right, for 3s, 1, 1, 1. So we need a 3. Right? For 5s, none, none, 1. So we need a 5. And the most x's in any one is 1. If you multiply this out, it should be 120x. So here's 8 times 3 is 24. 24 times 5 is 120. Right? So that is the other way to find the common denominator. And probably a better way than what I just did. All right, so you take this common denominator. I'm going to erase all this because it's kind of in the way. But you had to solve. You had to find that. So LCD is 120x. We're going to move it up here. Now, we are going to multiply everything by the entire LCD, just like you did earlier with clearing fractions. It's the same as clearing fractions before. You just have to watch out for these excluded values at the end. That's the only new part. All right, so we're going to cancel. All the denominators should cancel on this step. So 6 into 120 will go 20 times, and your x is going to cancel. All right, then you have 20 times 5 is 100. This one we have 24 into 120, and this I believe was 5. Yes, so this goes 5. Your x is still up here because it didn't have one to cancel with down there. So 5x times 7 gives us 35x. This 130 is going to go into 120 4 times. The x will cancel here. So you have 4 times 7 is 28. All right. Now we're going to solve. This is a linear equation. so we will isolate the variable. So you're going to subtract your 100. So I have 28 minus 100, negative 72. So I have 35x equals negative 72. Divide by 35. And I don't think this will reduce. It would change to a mixed number, but we don't want that. 35 has 5 and 7. They're both primes. Neither one goes into 72. So I think that is going to be our answer. We have to take one more step. You have to look back and make sure you didn't throw this value away, negative 72/35. No, we threw away 0. So we are good. And there you go. All right. Let's go back to problem number 5 and look at some of your other kinds of problems. So we have 3 over x minus 3 plus 4 equals 5. Okay, first of all, we're going to see what do we have to throw away. And the only denominator we have is this first one. So you set it equal to 0 and solve. And it's going to be a 3. X equals 3 is a bad value. So we're going to say x can't be 3. Right? If you have trouble seeing it, set it equal to 0 and solve. That's what we threw away. Right? Next, you pick your LCD, least common denominator. It is going to be x minus 3. The others are over 1. So that's our common denominator. So you're going to multiply every term by x minus 3. Right? All your denominators will cancel. So we have 3 plus, this 4 is going to distribute 4x minus 12. And this 5 will distribute. So 5x minus 15, right? It is a linear equation because the exponents are 1. So you want to get x on one side. I'm going to move the 4x to the other side. And I should have cleaned those up also. I can do that at the same time. You guys okay if I do that at the same time? So 12 minus 3 gives us 9. What's your sign? Sign of the larger. This will give us x minus 15. All right, add a 15 to both sides. So if x equals 15 minus 9 will be 6. All right, we have to look back and make sure we did not throw 6 away. We threw away 3. The answer is 6, so we're good. We can keep 6 for an answer. And that is what we should have. All right, I wanted to do one more before we got one that we have to throw something away. Maybe we'll just do it in order. All right, so we'll go ahead to 6. This one is asking you some other kinds of questions here, but we'll first just go ahead and solve it. X over 3 times 3x minus 9 minus 6 equals 1 over x minus 3. Okay, so first of all, to find your excluded values, set all the denominators equal to 0 and solve. To do that, you have to factor here. So 3 times x minus 3. Right, so when we set this equal to 0, this 3 doesn't matter because it doesn't have a variable. So only this piece, and so x minus 3 equals 0, add your 3. So x equals 3. So we are throwing that away. This one gets the same. All right. So then you pick your common denominator. And we need to keep this in factored form. We have a 3 and an x minus 3. This denominator is 1, so we're good. This has the x minus 3, so it's covered by this x minus 3. So our LCD, whoops, wrong button. LCD is 3x minus 3. Now we're going to multiply every term by that on the top because we want to make the denominators cancel. And this one is going to cancel everything. I took the factored piece off, but so this one is going to wipe out that denominator and leave us an x. Right, this one is going to multiply by it because it doesn't have anything to cancel. So we have 3 times x minus 3. We'll have to be careful there. We will do that in a second. And this one we have 3 times x minus 3. The x minus 3 will cancel. This side is going to leave us a 1. All right, here, first of all, you have 2 negatives. That will make positive. You have 6 times 3 is 18. 18 is what you're going to distribute. So 18 times x will be 18x. And 18 times a negative 3 will give us negative, I need to write that, 18 times 3, 24, 54. All right, and I'm going to just kind of run back through that. All right, so I had a negative here and a negative here. That multiplies to positive. 6 times 3 is 18. Distribute the 18. So 18x and minus 54. Right, over here, everything canceled. Let's see, the x minus 3 canceled. We're left with a 3. All right, now to solve this, you need to set it equal to 0. So you're going to subtract a 3 from both sides. Whoops. I'm not going the right way. It's not a quadratic equation. It kind of looked like it, but no, it's a linear equation. So I'm going to isolate the variable. So put your x's together. So I have 19x minus 54 equals 3. Add your 54 to both sides. So 19x equals 57. And then I would divide by 19. And I am just going to check if that divides. And it does. So we've solved it. We get x equals 3, but we threw 3 away up here. So there is going to be no solution because we threw 3 away. So, and that would be your answer. So let's see how they ask us. Yes or no here. Does the equation have a solution? The answer is no. So if yes, you put x equals here, whatever it equals. If not, put D in E. Does not exist. Okay. Most of them won't have those steps for you. Most of them you will just have to decide at the end if it gets thrown out. And if so, then you say no solution. All right. We'll do one of these. So we'll do 7. So we have 8 over x plus 1 minus 3 halves equals 4 over 3x plus 3. All right, and let's factor this denominator. That's 3 times x plus 1. So it is an equation. So first step is find out what you have to throw away. So for this first denominator, it's going to be a -1. -1 plus 1 gives you 0. So we're going to say x cannot be -1. The next term doesn't get an excluded value because it doesn't have a variable. And so we're good there. And this one would also be -1. This piece will become 0 if x is -1. Right? Then we want to find the LCD. Right? We are already factored. So we're going to have to cover the 2 and the 3. 6 would be the LCD for them. All right, and we're going to need an x plus 1. That will be your LCD. So you're going to multiply every piece by that whole thing on the top. So you're using LCD, but you're not putting it underneath like an add and subtract problem. All right, so this one, the x plus 1 goes out. You have 6 times 8 is 48. This one, 2 will go into 6 3 times. You have to be careful cleaning this one up. So you have 1 minus, so it's going to be minus. 3 times 3 is 9. 9 is what you're going to distribute. So 9x and it's a -9. I shouldn't have just brought that down. That's not a good thing. All right, so let me clean this up a little bit. So I have this one in there 3 times. I have another 3, and I have a negative. So I have a -9 times x plus 1. That's what I need to be coming down here with. So -9x is correct, but I'm also going to have a -1. Sorry, a -9. All right. The other one, the x plus 1 will go out. 3 will go into 6 2 times, so that took care of that whole denominator. 2 times 4 is 8. So, hopefully, I did not mess anything up. Let's combine 48 minus 9. So, 18 minus 9 is a 9. So 39 minus 9x equals 8. Let's subtract 39 from both sides. And those are different signs. So subtract sign of the larger. And then you have to divide by -9. 2 negatives with division will clean up to positive. And we have to look back and see, did we throw this away? No, we threw away -1. So we're okay. This should be our answer. 31/9. All right. I'm going to skip 8. It's very similar. See, it has a lot of the same pieces. So we'll skip it. All right. Let's do question 9. This one has a lot of work on it. So we have x plus 1 over x minus 1 equals -10 over x plus 3 plus 8 over x squared plus 2x minus 3. All right, so we have to factor this denominator. Hopefully it'll give us the same factors we already have. So different signs. And we're going to use a 3 and 1. So 3 will go with the plus and 1 with the minus. And that does give us the exact factors that we have. So that will be our LCD. Also, let's state what is undefined, right? So 1 is bad and -3 is bad. All right, so we're going to multiply through by this LCD. You're using the whole thing. So x plus 3 times x minus 1. Okay, this one is going to wipe out everything and leave you an 8. Let's go back to see what these others give us. So the x minus 1 is out. I'm going to write these factors so you can see really what I'm doing. Okay, this one, the x plus 3 goes out. So we have x minus 1 times a negative 10. All right, and this one, everything canceled but the 8. All right, so now we'll have to multiply this all out. This is a FOIL on this side. So that's going to give us x squared plus an x plus 3x is plus 4x plus 3. Over here, distribute, you have a negative 10x plus 10 plus 8. Quadratic equation, you want to get a 0 on one side. So we're going to move these, and this is going to give us an 18. All right, so add a 10x. So x squared plus 14x. And this one gave us 18, so we're going to take away 18. So 18 minus 3 will give us 15, sign of the larger. All right, now to solve, factor, you're going to need 15 and 1, and we want different signs. So we want plus 14, so that needs to be with the bigger 1. And then we'll solve. So this first piece gives us x equals negative 15. This one gives us x equals 1. Then we have to look back. All right, we threw 1 away, so we can't have 1 down here. Right, and we threw negative 3 away, which is fine, we didn't get that. But we can have negative 15. So our final answer will be negative 15. If you say 1 with it, it would be wrong. The 1 had to get thrown out. So you always have to look back. That is an important step. So one of the answers got thrown away. You don't say D and E because you still have 1. All right. I think I'm going to leave this section. Let me just check. I had marked one more problem. 13. Let's see if it's a lot different. It's actually going to be very similar to what we just had. Okay? So we will skip it because we have another section. And it has a bunch of things in it. So and I haven't turned that quiz 8 on yet. I want to review it before I turn it on. I did open the quiz 7 if you guys were looking for it. Okay, so we are now on Mod 8, Homework 2. And these are going to be some applications. We're going to solve some word problems with a proportion. Proportion is another way you can solve equations with rational expressions, but they only work when you only have one fraction on each side. So we can use them for some word problems. So the first couple, or the first one, just ask us to give a rate. A rate is a ratio with different units on it, and a ratio is a fraction. So you're comparing. So this one says if you drive 140 miles and you use 10 gallons of gas, what is your rate? Right? So write it as a fraction. Put the words on there. So we go 140 miles in with 10 gallons. And we can divide the numbers out. So 140 divided by 10 equals 14. Your unit you can keep like a fraction. Miles per gallon. And they wrote the unit for us in words, but that's what it would be. And so we get 14. So that is how to get a rate, is write it like a fraction, keep your words, reduce it. and then you're good. All right. This one gives us a proportion to solve, so we'll go ahead and do it, and then we'll go back to some other rates on there. I was going to throw this one out, but we'll do it. Okay, so this is a proportion. It has one ratio or one fraction on each side. And you could solve it by doing multiplying through by the common denominator, 24x on each side on top. But if you have this special setup with one fraction on each side, you can do what's called cross products. So you actually multiply across the equals on the diagonal. So we get 15x, and you set it equal to the other cross product, 24 times 50. Okay, and we're just going to go to a calculator there. 1200. And then you solve. So we're going to divide by 15. So x equals 1200 divided by 15. X equals 80. There we go. So that's how we're going to solve these. The next couple, just go back to rates again. So it's not going to be an equation here. This one, it says she rides for 7 hours on her bicycle. What is the rate if she rides 84 miles? Your rate you would give in miles per hour. So you need the 84 on top. So she goes 84 miles in 7 hours. And you can divide the numbers out. This is going to be your ratio, miles per hour. So 84 divided by 7, 12. So she is going 12 miles per hour. All right, so there's your 12. And this one you had a drop down. You want the first choice. Oh, it's because I didn't type it in the box. Okay. So you're having to turn some of these around to make them make sense. You also will have to, on number 4, it says last week you worked 8 hours, you earned $58. What is your hourly pay rate? It doesn't make sense to put the hours on top. So you're going to have $58 for 8 hours. Divide it out. So 58 is 7.25. You still have your money here, right? So 7.25 per hour. This is one way to write per, is with just a slash. So $7.25 for every hour is the rate. And they put the per hour, so you just need to do 7.25. All right. This is a first one they give us that we can actually set up a proportion to solve, which is kind of the goal here. They just sidetracked a little bit. Okay, so when you have one rate and you have a piece of another one, you can make those things work at the same rate. And so you make an equation. So we are given one rate here. For 1 1/4 cup of sugar, we can make 20 cookies. So you would write that down, and I don't want to deal with that fraction, so I am going to do 1.25. All right, and you need to write your word on there so you'll know what it is. I put cups, so that's cups of sugar. for every 20 cookies. All right? And then they're going to ask you something else using that rate as your rate. So it says if you're going to make 14 cookies, right? So you're using the same recipe, you would want the same proportion of sugar to it. So you're going to make a proportion here. The piece you don't know, you're going to put for your variable. You don't know how many cups of sugar, and you want to make 14 cookies, right? Now you're set up, and you can do the cross products. So we're going to do 20 times x is 20x equals 1.25 times 14 17.5. Now we're going to solve for x. And x is going to be cups. Whatever you have over here, this will be the same. Cups of sugar. This is cookies. You put them in the same position going across. All right? And so the 17.5 is going to be cups whoops, we haven't finished solving yet. Okay? Divide by 20. So x equals 0.875. They're probably not going to like that answer in the software. And this is cups of sugar because that's what we're solving for. So let's change this 0.875 to a decimal. I believe if I hit this arrow right here on this calculator, it will switch it. And that is 7/8. So x equals 7/8 cups of sugar. Almost 8. Almost 8/8, which is almost a whole cup. So a cup, if you're using your measuring cups, a cup, and take a little bit off of it. All right, if you don't have eighths. All right. The other thing you could have done if you have that 0.875, let's see, here it is, fraction to decimal. Most people have a fraction to decimal. So if I have that 0.875 in here, if I didn't have these little arrows, which are just on certain calculators, I could look for that F to D, and it goes both directions. So it's above that button. So I'm going to do second, and that button, enter, and it gives me the 7/8. So that is another way you can switch. All right. So 7/8 of a cup of sugar. All right, a couple more of these and we'll go to the formula problems. This is an example with similar triangles. Similar triangles have sides that are proportionate, and you can make your ratio with matching ones or within one, and then the other should be the same. You have to use the side that they want to solve for. So they're going to solve for V, right? So the triangle that we'll use to set up, let's use the MOP, M-O-P, right? They're doing the angles there. And so let's do the long one over this shorter one. And this shorter one, if you flip this over, is going to match this V. All right, so I have 90 over 45. This one is my long one over the shorter one, right? Which 90 is matching to 60. Well, that V is shorter. I think that probably it rotates that triangle too. not necessarily to scale. All right. So out of this one, I had to go in the same direction if I'm taking them from one triangle. So I did the longer one here and over this, so I have to do the longer one here over this one. So this is longer. All right, and we'll try this. I had to use the side that is V. Okay, so 90x equals 45 times 60, 2700, and divide by 90. So x equals, this should be 30. So let's see if they like that answer. Good. The other way you could have set up here is you could have gone from triangle to triangle. So you could have done, so you can make a ratio in one triangle and match it to the similar one, or you can go triangle to triangle. So I could have done 90 to 60, and I did this triangle first, so then I have to do 45 to the V. They are assuming this triangle would flip over, and it would flip 2 times to make those match. All right, let's see how we do here. So it gives us 90V equals, and you actually get the same numbers even though we had a different setup. We had 90 over 60. Here we had 90 over 45. So you can set it up either way with similar triangles. So you can make your proportion and solve for the other one. All right. I am going to go down. Let's see. I'm going to run out of time if I do that. Let's do 8. We can do 8 and then we'll go to the formula problems. This one just has so many words, I know you're not going to like that. Okay. All right. We're going to turn it into a proportion. And proportions are actually easy word problems to solve. All right. So it says, suppose you work for a large coffee distributor that has a secret coffee blend it sells to stores. You mix the house blend with the terrazza blend, always in the same proportion. Yesterday you mixed 90 pounds of the house blend with 27 pounds of the terrazza blend. Okay, so that's the ratio that you want. All right. Today there is 80 pounds of house blend left. You need this to go in the same position you had the house there, because sometimes they might switch the words. So now you're going to solve for how much of the terrazza will you need. And so we're going to go cross products. 90x equals 27 times 80. $21.60 and divide by 90. So x equals 24, and this was pounds of the terrazza. And there you go. Okay, let's go to the formula problems at the bottom of this section. And you've done some formula problems before. You can't solve for the one that you want cannot be left in the denominator. Okay, so we'll have to multiply through by the common denominator thing. So we have P over D plus B equals G over D. Right, and we want to solve for D. All right, so we can't solve for D in the denominator. So I am going to multiply through by the common denominator, which is d times d plus b, and get all the d's out of the denominator. So d plus b times d, right, and d plus b times d, right? Match up and cross off. So I end up with dp equals, here I'll just write down what I have first. All right, we want to solve for d, so we're going to need to get the d's on the same side and nothing else over there. So let's distribute this g because we want to get the d out of the parentheses. Okay, so this side is just hanging out. So we have gd plus gb. All right, now you have d in two places. Get them on the same side. So I'm going to subtract the gd. From both sides, you took it off of here, so it's gone. Now you're going to use a factoring trick, right? Because we just want d in one place. So it is a GCF here. We can take it out, right? That leaves p minus g. All right, now you can solve for d. D is multiplied by all this piece, so you're going to divide by p minus g. This is gone. D is isolated. That was your plan on this word problem. Whoops, that's not a Q. We didn't have any Q's. That is a G. All right, and they didn't write theirs exactly like I did. What I wrote is fine. Their G is times this. It would put it on the top. Okay. We'll type it in so you can see. So you would want fraction button first. GB over P minus G. And it had the D equals, so I don't have to put that. There you go. So that one was a little advanced, okay? Because you had to do two things. You had to get rid of it out of the denominator, but you also had to use a factoring trick because you had it in more than one term. All right, let's see about 12. So we have 5 over R plus 3 over S equals 3 over T. And we want to solve for R. That's the one we want to isolate. The first thing you have to do is get the R out of the denominator. So we're going to get rid of all the denominators. The LCD is RST. So you're going to multiply that by each piece. Right, and each one something will cancel. So here we're left with 5ST. This one you're left with 3RT. And over here, you're left with 3RS. Right, and we wanted to solve for R. So you have R in two places, get them on the same side. So I'm going to subtract this one. And I moved it over because they're not like terms. So 5ST equals 3RS minus 3RT. Okay? And I am going to factor there the R out. And I'm doing a GCF. I can also do the 3 if I want. Okay? But the R is what you really want out. So I can do 3r times s minus t. Okay, and now I want to solve for r. So I'm going to divide on both sides by 3 and s minus t. That will isolate your r. So this is our final answer. They can put different forms of this there. We will type it in. So we'll do a fraction button. 5, and they had capitals, so I need to use capitals. Good. All right. Let's just look and see if there's a lot different. 14 is really old stuff. Formulas, so it's not a big deal. 13 we can do. These are 2-step ones, so they're not really going to be like that. So let's go back. We'll do 13 and then we'll stop. So we have y equals 10 over 3 minus x, solve for x. Okay, so we got to get the x out of the denominator. So your common denominator is 3 minus x. So we're going to multiply that on both sides, 3 minus x and 3 minus x. This one will go away. Right over here, right now, we have 3 minus x times y equals 10. All right, and we want to get x by itself. So let's distribute here. So we have 3y minus xy equals 10. Now, watch on this one. You're trying to get x. X is what you want to isolate. You really don't need to factor out here because that's going to just put you right back up here. We want x by itself and nothing else there. So we have a choice, right? If we want to keep the x on this side, we have to subtract the 3y and divide out the negative y. Or we can move the, it'll be about the same. You could move the xy and move the 10. It doesn't matter. All right, so I'm going to move the 3y. So I have negative xy equals 10 minus 3y, right? And I want y. No, I want x. So I'm going to divide by negative y. Right, that isolates my x. I'm going to enter the answer like that. Sometimes they don't like that negative on the denominator. There's nothing wrong with it mathematically. I just want to see if it's going to mark us up. So 10 minus 3y. Whoops, and I had caps on. I don't want caps here. It would mark me wrong for that. Over negative y. Oh, they want the equation, so they want x equals. That's what that red clue meant there. And this is an issue. It would mark me wrong here because the x ended up on top of the fraction. I wanted to be in front of the fraction. All right. So we'll see if it's going to fuss about that negative on the denominator. No, it's fine. You could have distributed it through the top. Okay. All right. I think that is enough work for today. So you guys have an awesome day. Thank you for coming.